Welcome, future certified phlebotomists. You've probably mastered the blood draw, but what about everything else? Well, your certification exam will absolutely test you on non-blood specimens. So in this explainer, we're going to master the critical rules for these samples, making sure you walk into your exam with total confidence.
Okay, let's kick things off with a question that points us directly to a major section of your exam. Which non-blood sample type involves legal requirements, super strict security protocols, and even has its own multi-part federal form?
The answer, of course, is urine drug screening. And to get every single question on this topic right, you have to master one core concept, the chain of custody. Getting these rules right is totally non-negotiable, both for your exam and for your future career. Now, this whole process isn't just some boring checklist. Think of it more like a legal shield. It's designed to make sure that from the very moment of collection to that final report, the result is legally defensible. Every single rule is there for a reason, to protect the sample's integrity, the donor's rights, and the validity of that final result. For your exam, you definitely need to know these specific actions that prevent tampering. These are the core requirements from the Department of Transportation, or DOT, and they're pretty much the gold standard everywhere. For example, adding that bluing agent to the toilet, that's to prevent dilution. And securing the area means checking for anything, soaps, cleansers, hidden liquids that could be used to mess with the sample. And here it is. This is the first and most immediate check against sample tampering. A substituted sample, one that someone sneaks in, will almost never be at body temperature. This range is one of those numbers you just have to commit to memory for your exam, 32 to 38 degrees Celsius. And just so we're clear, this isn't a suggestion, it's a strict rule with a time limit. A sample that's too hot or too cold is a huge red flag for substitution. So the key takeaway is twofold. You have to check that temperature strip within 4 minutes of collection, and you have to document it correctly on the custody and control form. Now, what's really fascinating here is how this form creates a whole web of accountability. The Federal Custody and Control Form has 5 copies, and each one has a specific legal purpose. You need to know who gets what. Copy 1 always travels with a specimen to the lab. Copy 2 goes to the medical review officer, or MRO, that's the doctor who interprets the result. And the rest of the copies create a clear paper trail for you, the collector, for the employer's rep, and finally for the donor. It guarantees transparency from start to finish. Okay, let's switch gears and talk about 2 of the most critical fluids you'll ever handle. We're now dealing with irreplaceable samples, cerebrospinal fluid, or CSF, and amniotic fluid. With these, a handling error isn't just an inconvenience. It can have severe, direct consequences for the patient. There are absolutely no second chances. Let's be crystal clear about the stakes. Cerebrospinal fluid is collected to diagnose life-threatening conditions like meningitis. If you handle this sample the wrong way, say you compromise the viability of the bacteria the lab is trying to grow, it could lead to a false negative. That means a missed or delayed diagnosis with potentially devastating results. The stakes really couldn't be any higher. Okay, listen closely because this is a classic exam trap. We're so often trained to think cold preserves things, but for CSF, it is the absolute opposite. The organisms that cause meningitis and the cells needed for a count are incredibly sensitive to cold. So burn this rule into your brain. CSF tubes for microbiology and hematology must always be kept at room temperature, no exceptions. The collection order for CSF tubes is so important and it must never, ever be changed. Tube 1 is usually for chemistry because it's the most likely to get contaminated with a little bit of blood from the puncture itself. That makes tubes 2 and 3 cleaner, which is why they're perfect for microbiology and hematology. And of these, tube 2 for microbiology is the absolute top priority. It has to be delivered stat at room temperature to give those fragile organisms the best chance to grow in the lab. I know students get the handling for these 2 precious fluids confused all the time, so this slide is really key. For both, room temperature is crucial for any cultures, but the big difference you have to remember for your exam is light protection. Amniotic fluid being tested for bilirubin, which helps check on the health of the fetus, has to be protected from light immediately. That means using an amber tube or wrapping it in foil, because light literally breaks down bilirubin and will cause a falsely low and therefore incorrect result. All right, let's cover a couple of specialized samples that each have their own unique and very testable handling rules.
You might not see these every single day, but a question about one could easily pop up on your exam, so let's make sure you're ready.
So, the crucial point for urine alcohol is stability. First off, it doesn't show current impairment like a blood test does. But more importantly, for your exam, you need to know about fermentation. See, if the sample has sugar and bacteria, which is common in diabetics, the bacteria can literally eat the sugar and produce alcohol as a waste product, right there inside the tube. This creates a false positive. To stop this, the sample has to be refrigerated immediately, or collected in a special tube with sodium fluoride preservative. This is a key visual clue you might be asked about when it comes to gastric aspirate. When you get a sample of stomach contents, the way it looks can tell you a whole lot. So, what does this specific description mean? This is the perfect example of why your careful observation is so important. A coffee ground look is the classic sign of old digested blood, and it points to a bleed somewhere in the upper GI tract. As a phlebotomist, recognizing this and immediately escalating it based on your facility's protocol is a critical part of your role in patient safety. All right, we've covered a lot of critical information. Let's lock in the most important facts with a quick review. Think of these next few slides like digital flashcards to really test what you know. First one, this is that critical number from the very beginning. What is the acceptable temperature range for a urine drug screen, checked within 4 minutes? That's right, 32 to 38 degrees Celsius or 90 to 100 degrees Fahrenheit. It has to be right in that range. Next up, think about that critical fluid for diagnosing meningitis. What's the absolute must-follow rule for its transport temperature? Correct. Room temperature. Putting it on ice is one of the biggest mistakes you can make because it can kill the very organisms the lab is trying to find. And what about this common test on amniotic fluid, the one used to check on a fetus's health? What is the one special handling step you can never, ever forget?
Exactly. You have to protect it from light from the moment of collection. If you don't, you're going to get an inaccurate result. Simple as that.
What you do as a phlebotomist matters so much more than just the collection itself. Every one of these rules, from temperature checks to light protection, directly impacts a patient's diagnosis and their care. Mastering them ensures you are a critical, reliable, and truly indispensable member of the healthcare team. You aren't just a collector. You are the guardian of the specimen's integrity.